Okay, so we're saying that up until now, we have looked at the use of some functions. We have looked at different functions. We have looked at the print statement, the print function. We have looked at the len function. We have looked at when we try to typecast and convert from one data type to another. We use functions that are related to, like, for example, a string function. You can use a Boolean function to convert a certain data type into a Boolean. So now, when we come to functions, so functions are basically these blocks of code, yeah? They are basically blocks of code that are reusable, and of course to perform a specific task. That's what basically a function is. So I'll take an example of, like, for example, print. Okay, so this is a statement that we have seen from the start. Okay, a print statement. Now, what we don't know is that actually there is code behind this print statement. Okay, so there is a whole block of code that is activated whenever I try to run this print statement, right? And if it was to keep, if we are trying to, if for example, if we wanted to print something and we are to use that same block of code every time, our programs would really look so messy. And therefore, that's where the idea of functions comes in, that we just want to write the code once and just keep using a function without rewriting the original code. Now, it's a simple thing to do. So we use this keyword, okay, the def keyword. So when we use the def keyword, we are basically telling Python, let me try to increase this, yeah. So we are just telling Python that we are going to basically define a keyword, to define a function. So using this keyword, this is called the def keyword. I'll have to remember it as a short form of define, okay? So for example, we're trying to define a function. So we use that def keyword, and then we give a function name, right? So a function name. And when you get that function name, okay, it's simple as that, right? And when you when you define the function, you write your code, right? You write your code there, and then whatever code you want to run, right? So for example, let me comment this, and let's see what a function looks like in practicality. So let's say, for example, we have a function, right? I want a function called, say, hello. So this function, say hello, we want this function, say hello, to maybe print out hello. Okay, let's just keep it simple and try to print out hello. So when I come and run this cell, of course, I see that nothing is printed out. Yet I said define the function, which is say hello. And by the way, whenever you are defining a function, make sure that you put these two parentheses, all right? So that's what Python just knows immediately, that you are trying to deal with a function. So when I run it, I get nothing, but to get the result that is under this function definition, I have to call the function, or most people say invoking the function, but it is basically calling the function. And calling the function is basically calling it by its name. So I want to say hello. Now, when I say that, when I run, I see that we get the result, which is the print. Okay, so which is the statement in this print, the string in this print. So you see that there is a similarity between when we say hello, and you see when we have this print, for example, let's eliminate, so for example, let's remove that. So do you see the similarity between the two? So when we write this print function, it calls, when we write this print statement, it calls the function that is under the print. So now it is the same thing that we are doing here, that we are trying to run code that is under the function definition. So when you define your function, write code under it, make sure you call the function so that it basically returns whatever you wanted to return. So what if I said, maybe I wanted to, what if I said print, say hello? Yeah, so if I do that, it's just going to basically return, it should, when I do this, it's going to, with that extra. So when I do this, it's going to return this is the location of this function in memory. So that's what happens if you do not print out if you just do not include these parentheses when you are calling the function. So what we are standing for here when we use functions is a principle which we call dry. Okay, so dry is a software engineering principle, which basically means, yes?
I need you to elaborate again on two things. One, is the part when you went back up on print hello world and you deleted the hello world and you only remained with parentheses. I didn't understand what you were trying to do there.
Okay. Second.
Then, the last code we ran, print say hello. I don't know why it's returning this code that we have down here. I didn't understand you properly.
Okay, so what we're just trying to basically elaborate is, you see, we defined our function here, which is say hello, all right? And we have a print statement under it. We want our function, whenever we call the function, we want it to say hello, isn't it? So when I run the function and I try to call the function in order to return this, I was showing you that you have to include these two parentheses, simply just like how you see it in the print statement here. So this is basically the fundamental of functions, that whenever you're calling the function, you have to call the function with its parentheses. And I'm saying that if you do not add that parenthesis, for example, you say here, we just have say hello, we just have the name of the function without its parentheses, it just returns where the function is stored in memory. It does not run.
So Josh,
yes.
If you put a double parenthesis on print say hello, it would then print say hello.
So it is going to tell me, it's going to print, it's going to return what is there, but we are going to see what it is, what's happening here, why it's saying none. Okay, it says none here because of something which it's returning. The function is returning nothing, but it is printing. Say so. This is I didn't want to go here, but we're going to look at it towards the end when we are dealing with the return keyword. So first ignore this, okay? But you see that if we put our parentheses, the function again runs and prints out. It prints out the hello. So, but if you call the function without putting those two parentheses, it will just simply return where the function is stored in memory. So, and the reason why, yes.
One last thing on cell 6, yeah. When we said def say hello, yeah. and you print hello.
Yes.
Um, um, so then in the next cell you run the code. God,
So I think what's confusing you here is this, that I have put this here. So let me try to put it this. When I try to run this cell without calling the function, I get nothing. The function doesn't run because I have not called it. Okay, I have defined it as say hello, and I've put code under it. Okay, so this is my whole function. But for it to print hello, I need to call the function with its name, and that's why it prints hello. So the rule of thumb is whenever you define a function, make sure that you call the function. So define the function and call it if you want it to do what you intended it to do. So Rodney, you have your hand up.
Joshua, mine is I try to type the print say hello. Yeah, on the 18th line, right? But mine on the 18th line.
Yes.
Yeah. So, but when I run it, it doesn't bring me the location of the function in memory. It brings me hello, none on the next line. What could be the problem there?
That when you run this cell, what happens?
It brings me, it returns hello, and then the word none.
Because you have put this, you have put parentheses. I told you when you put parentheses, it's going to do that. It's going to return hello and none. And I said I'm going to explain what none means. Okay, I'm going to explain what this none means. It is a data type that we saw earlier, but when you remove them, when you just say print and say hello without those parentheses, you're going to get the memory.
I thought when I put in print say hello, it brings me whatever is under the function say the say hello.
Okay, you paste your screenshot within the group. Paste the screenshot within the group, because if you do not include these parentheses after the function, after calling the function, it has to return the it's going to tell that this is the function say hello at that storage, at that's location in memory. I'm saying that mine does not print because you have not called the function. I think this is Flavia. Flavia, you have not called the function. You have defined the function, yes, but you have not called it. This is calling the function, okay? You have to call the function, okay? So whenever you define a function, I'm going to repeat it, define the function, okay? And then call the function. If you do not call the function, it's not going to print this hello. It's not going to return anything, right? So now make sure that you always call your function whenever you define it. So let us continue. I was trying to say that why do we use functions is basically to try and enforce this. Yes. Yes.
Maybe to help you, I'm sorry I'm driving, but I'm following through. Maybe to just help you explain the concept that you're trying to put forward to us, yeah, for the others to benefit. I'll just maybe, if it's okay with you, I can just give them maybe, I can try to come up with a scenario, yeah. For example, if you're a boss and maybe you define, just give an example. You have some workers, you have someone that's supposed to clean your table. And the instructions you've given them is, please, your work is to clean the table with a mopper. So when you're in your office, and maybe, for example, the name of your worker is called Brian. I'll give myself Brian. Then when you're in office and you say, Brian, you already gave instructions to Brian that wherever I call you, your role is to clean the room. So then when you're in office and you just flip out and it's called Brian. So Brian comes, he doesn't have to ask what he's supposed to do because already defined and he said, your role is to clean the room. So when you call Brian, Brian will come, clean the room, then you go back. So that's actually what is trying to happen here. You define your function, you say you're going to be able to do X, Y, Z, M. So right now, the example you've given us, it's supposed to print the word hello. So after defining it, you've already given them instructions. You come down and now you call. When you call the function, he knows that it's supposed to be printing hello. Do whatever is happening. Thank you. I just wanted to maybe bring it down to the other members. I appreciate the question. Thank you.
Yes. Thank you. Thank you for that. Thank you for that real life example. So define your function and always call the function. That is a rule. So now, when we use functions, we are trying to keep our code dry. Okay. So dry is do not repeat yourself. Okay. So when we are trying to use functions, we are basically trying to keep our code dry. Now, this is a principle, as I was saying, that it's a principle in software engineering that encourages code reusability and maintainability, so by avoiding duplication. So you are trying to avoid, so for example, if I wanted to print the word, print this word hello, to print this thing hello, and let me say, and I wanted to, I write it here, again where I want to print hello, I write it, again where I want to print hello, I write it, again where I want to print hello, I write it. Instead of doing that, I can just simply call the function every time I want. I can just simply call the function every time I want to return something from that code, right? So it keeps our code simple and easy to maintain, so that when other developers come to look at it, it's less, it's less, it's not too wordy, not too much. It is, you just keep using the same function all over and over again by just calling it, right? But there is also another principle which is called wait. Now, wait is basically write everything twice. Okay, so write everything twice is what you would do if you are not using a function. So that is if you enjoy typing, but you just can keep your code dry by calling functions. And this wait principle really leads to code duplication, and that code is usually hard to maintain. So now I wanted to show you something. Now, for example, let us go to, in the previous class, we wrote a small password checker. I think this was it. This was the code that we wrote in the previous class. So let me just copy that code. Now, imagine that we wanted to keep using this password checker every time, right? We wanted to check for the password every time. So what we can do is basically write this under a function, and we say password checker. All right, so let's call it password checker, and make sure that we put our full colons. But remember, Python is very sensitive when it comes to indentation. So highlight this code and press a tab. Okay, so you press a tab and let us get. Actually, this code is supposed to be inside here, since it is part of the password for the password checker. So now when we run this code, when I run this cell without calling the function, nothing happens. But when I call the function password checker, okay, so when I call the function password checker, it is just going to immediately now ask me to enter my password. So immediately I say admin 123, access granted. But I want you to imagine the situation whereby if you were going to check for the person's password and you had to keep writing this code a thousand times, your code would really look so not neat, and it would be hard to maintain. So it is very pertinent to understand the principle of functions, in that you can keep reusing your code. So if something went wrong with this function, I would just have to come and check in one place where I defined that function, other than if I kept writing the same code all over again. You have to now visit different files to keep checking where you wrote that password checker. So, but when you write one function and just keep calling it, you keep your code dry. You do not repeat yourself. And that is the beauty about functions, right? So, but functions in themselves are really so not powerful if we do not have, if we are not able to make them a little bit dynamic. And to bring in the concept of dynamicity, we have what we call parameters and arguments. Okay, parameters and arguments. And let me make this markdown so that we can see what parameters and arguments are all about. So parameters are basically placeholders, okay? They are placeholders in the function definition when we define a function. So parameters, these are basically these are placeholders in the function definition, okay? So when we define a function and we get variables that we put within those parentheses of the function, we have created what they call a parameter, okay? So these define what input the function can receive. Function can receive. Now we have also what they call arguments, okay? Now I don't want you to confuse the two, parameters and arguments. They are sometimes used interchangeably by different people. Someone says arguments when they actually mean parameters, and someone says parameters when they actually mean arguments. So it is common to confuse the two, but to understand, to differentiate the two, is parameters are within the function definition, and arguments, on the other hand, they are the actual values that are passed. We are going to see what I'm trying to mean, that these are actual values that are passed during a function call. Okay, so let me just make this a markdown so we can keep seeing that text. Now, let me now, for example, say, let me define a function, right? We have seen the def keyword. So, and this function is, say, name. Maybe we want to print a function that prints both names. So say name is taking in two parameters. Okay, we say these are just simply variables that are passed within the function definition. All right. So first name, and maybe we say second name. Okay. So what do I want? I just want, after the function has received my first and second name, I want it to print. Let's use an F string. Okay, we saw F strings in string formatting. I say maybe hello, first name. Here, let me get this. Okay. So F string first name, and also the second name. Okay, so I basically want my function to print out my first and second name. So when I write that code and I call the function, say name, I want you to note something, that if I just call it the way we were calling this function here, which was saying say hello, and this is empty, if I run this, I'm going to get definitely an error, which is going to tell me that say name is missing 2 required positional arguments. And this is first name and second name. So how do I fix that? You see that our function here, when we defined it, we said, say name, we want you to take in the first name, and we want you to also take in the second name. After taking in the first and second name, we want you to print hello, first name and second name. So to solve this error, we actually have to give our function here, when we call it, we need to give it arguments. These here are parameters, okay? So these are the parameters. Now we need to provide it with arguments. So if we say maybe eine, comma, and we say Provia, okay? So it is going to, now when we print out, it's going to say hello eine Provia. So in this part here, we are trying to provide, to satisfy what the function requires. The function requires arguments here, but we defined our parameters up in the function. So I don't want you to get confused. Just it's a simple concept to understand that when you provide a parameter, you have to also give an argument. So let's try to see that another example again. Maybe let's say we want a function that's going to greet. So we define greet me, okay? So, and maybe it's taking in a name, right? We just want the function to greet us. So greet me, and we have given there a parameter name. So simple print, we then have string. I say hello, and now we want you to print out the name, right? So when I come and call the function greet me, I have to definitely give it an argument, because you see that the function has a parameter. So we need to give it a name. I can say maybe Johnny. And when I say Johnny, it's going to tell me, hello, Johnny. Okay. So in this part, name is a parameter. Okay. Name is a parameter. And down here, we have Johnny. Johnny is an argument. Okay, so this is very powerful in that it allows our functions to become more dynamic. Okay, it allows our functions to become more dynamic, and we're going to see why we actually need to have functions, to have parameters and arguments. So let us write a small fun project. Let's say maybe this is, we want to check a mobile money. Let's say maybe a mobile money balance checker, maybe something like that. So in this mobile money balance checker, we are going to write a function that is going to check our balance, all right? And to check our balance, let's define our function, which is called, maybe you can call it check balance. When we open that, of course, we have seen how we define our functions. But when you're checking the balance, let's say, for example, we want to put in the name and we want to put in our PIN, isn't it? Though it is not common that you put in the name, but let's say, like, for example, our function requires it that in this case, you need to put in your name and you need to put in your PIN. So let's first define our correct PIN, because correct, let's say, like, for example, our correct PIN is maybe 1, 2, 3, 4, okay? And we can say that maybe our balance, okay? Let's make it hard-coded, and maybe it's 20,000, okay? So We are using a fixed balance for, of course, these are demonstration purposes, and the correct pin is also for demonstration purposes. So now let us write our if statement to check if when the user puts in a correct pin, okay? When the user puts in a correct pin, we tell them the balance, and we also tell them their name. So let's say if pin, okay, or it's if pin, which the user is going to put in here, okay, if pin is the same as correct pin, okay, we have defined our correct pin down here as 1, 2, 3, 4. So we want if the user pin that they have put is the same, or if it is equal to correct pin, which is 1, 2, 3, 4, okay, what should happen? We want you to print, let's use, so string formatting comes in a little bit here. So hello, and name. So for example, if I logged in and said my name is Joshua and my pin is 1, 2, 3, 4, it should tell me that hello Joshua, your balance is this. We are basically checking for the balance. So here we have hello name, okay, hello name, and put a comma. Your balance is maybe UGX. Now let's put in this thing that we need to return. We need to return this actual balance that the user has on their mobile money. Okay, so your balance is that. Okay, so else what happens if the user puts in a pin that is not correct? Okay, else make sure that you indent your code properly. Indent your code properly. So if the user puts in a wrong pin, let's say maybe incorrect pin, okay? Try again. So we have our function, check balance. It is asking for the name and the pin, okay? But we have already defined a correct pin, and we have defined the balance, okay, under the hood. These are hard-coded. In most cases, of course, in real life, these are not hard-coded, okay? But now we want to check if pin is the same as correct pin, print that hello with the username, your balance is, returns the balance, or else if the pin is not correct, you print out incorrect pin, please try again. So now let us come and collect user input, okay? So that is our function. But now we want the user to come and put in the name actually. So username is equal to input, enter your name, enter your name. We have seen what the input function does. And user, now we want to collect the user pin as input. Now let's tell the user to enter the pin, okay? So when we tell them to enter the pin, we need now to call our function. So when we check balance now, okay, when we call our function, check balance, we are taking in two items, which is the username, and we are taking in the user pin. So we take in this username, okay, and we are also providing it with the user pin. So when we run this, it's going to tell me, please put your name. I'm going to say Joshua. Please put your pin 1, 2, 3, 4. And when I run that, it should tell me that should tell me that, hello Joshua, your balance is 20,000. Okay, so now that is of course this is a small example of what arguments and parameters are all about. Okay, so they are very useful, that they make our function more dynamic. They help us to create apps that are more dynamic, apps that are more useful, apps that are more strong. Okay, so now I wanted to, if that is clear, I wanted to continue and write some code in the part of what we call default arguments and also keyword arguments. And I'm going to show you what these are. So we have what they call default arguments, and we have what they call keyword arguments. Okay, so what are default arguments?
Josh,
Yes.
when I enter PIN, the thing does not return anything. I wanted to understand also where we defined the username, because I don't think I see Joshua anywhere in the code we wrote here.
You don't see where Joshua is because we are collecting user input here. We're collecting user input. Collecting input. So when you collect the input here, I just basically ran the function, and I can just say, Jane, what's the password? 1, 2, 3, 4. And it's going to tell me, hello, Jane, your balance is that.
Okay, when I run my code and then I enter PIN, I don't, it returns nothing. It returns an empty cell.
Screenshot in the group, and then we shall try and troubleshoot where the problem is. So you can also cross-check with the code that I've pasted in the group. Okay, so I've pasted my code in the group. So now
I have a question.
Yes.
Why we save the PIN as string and the balance as integer?
Why did we do this as string and we said balance as integer? So of course the balance is an integer, it is money. Okay, we can also make this, we can decide to make it also an integer. Okay, decide to make it an integer, it is fine. But when we are collecting input here, remember that what you input here is basically a string. Okay, what you input here is a string. So that is why I put this as a string, so that I do not have to do type conversion, that I do not need to convert it back into a string. But I can do it and do something like this. But when I'm collecting my input here at the user PIN, I make sure that I convert the type into an integer, because the input function collects a string. When what you input is a string. Are we together?
Yes.
Yes. Okay. So let us continue, and I show you. I wanted to bring in this concept of default arguments.
Excuse me, Josh.
Yes.
My code is when I run, I put in the username, then put in the PIN. When I run again, it shows the name error. Name username is not defined.
Did you define it here?
The name is equal to, yes, I did that.
Give me a screenshot. Give me a screenshot. I look at it. So
okay. Also, I had a question up there on when you go back to where we're saying say name Aine Provia, where you are teaching us, showing us the parameters and the arguments. When maybe later I want to call the same name again, do I have now again to say name Aine Provia?
Oh, no. Now this is
later.
Later now, no, you do not need to do that. You just give it different, you give it different. I can, okay. You can give it different things and it will print out. So here you're just trying to make sure that whatever is stored in this variable is not static, it is dynamic. It is you who determines what you want. So for example, you have gone to, you have opened your banking app and then it just automatically tells you, hello, Grace, how are you? And then I will open it, it will tell me, hello, Josh. Another one will open it and it will tell them, hello, maybe Flavia, something like that. So it is collecting the name that you put in dynamically and it is displaying it. So static means it is one thing, it's hard-coded. But when something is dynamic, it changes over time. Are we getting the argument?
Yes, that's clear.
Okay. So now let us try to, I wanted to, because functions are really so sweet. I love functions. So let's try to, let me bring in what, I try to show what default arguments and keyword arguments are. So let's say maybe we have that function again, say name, okay? But now, let's say it is collecting, of course, the first name, and we are inputting maybe the gender, okay? The gender. And we want it to maybe print. Let's put our F string and say, hello. Oh, sorry. Our F string, we need to, wanted to say hello, and then we get our first name. Okay, so we want it to, when you put in the first name, just tell you something like, hello, Josh, your gender is this. Okay, that's the kind of thing that I want to implement. So your gender is, and then we get male. Sorry, not male. We collect gender right there. So when we come and let me just run this and go in another cell and call our function, say name. We give it Joshua, and then we give it the gender, which is male. Okay, so male. When you run, of course, we see it tells us that, hello, Joshua, your gender is male. But now let's say, for example, I switch these two things. Okay, let me just copy this thing and paste it in here, this same line of code, and now switch places. I say male, it comes first, okay, and then Joshua comes last. So when we see something like that, of course, it's going to tell me that, hello, male, your gender is Joshua. So which is really not what we intended the code to do. We wanted it to print this. So now what these are, okay, these arguments here that we have put in here are called positional arguments, okay? So these positional arguments, they follow the position of the parameters. You must not make a mistake and switch the two. Otherwise, your code is going to print things that you do not understand. So these are positional arguments in that they do what? They match the parameters by name. They match parameters by name. And when we come, we can correct this, okay? And now remember, it is telling us that hello male, your gender is Joshua. So we can use what they call keyword arguments, okay? So I can say maybe can call them keyword arguments. And I can just basically here come and say, gender was actually supposed to be male, and name, is it name or it was first name? So first name was actually supposed to be Joshua. Now, when you run it, you see that it is corrected. But I argue that this is a bad practice, okay? I'm not saying that using keyword arguments is a bad practice. I'm just saying that why can't you just basically keep things in the order that you did them? But these are what keyword arguments are. So you just basically get we try to reassign them, and we say that first name is actually Joshua and gender is male. So it corrected it in the output, because when you look at the function first name, we were collecting first name and we're collecting gender, okay? If you do not specify which one is which, you are basically using positional arguments, and you have to follow the order that was given, okay? The order in which the parameters are first name first, gender last, okay? But if you are a little bit crazy and you want to say put first name last and gender first, then you have to specify which one is coming first, or which one are you trying to mean. That I'm trying to mean that gender is male and first name is Joshua. So when it's printing out, it knows where to place those items. So now let us try to see something else. I hope we are following. So you see, if I come, let me delete this. Actually, let me just use a different, say maybe Jenny. I don't know if that name exists. And we say maybe Jenny is female, okay? So we call that and tell us, hello Jenny, your gender is male. But what if I missed out? Okay, what if I put only one argument? So when I print that, it's going to throw an error and tell me that the name is missing one required positional argument, which is gender. So in here, gender is not provided, okay? So I want to show you what we call default. So let me first get this thing, and let me just recopy this code. We keep this one for reference, okay? Let's keep it for reference. Now, if I come and run this code, I can say that maybe if we do not have a first name provided, or if we do not have a gender provided, let's use some defaults, okay? So I can say first name is equal to maybe John, okay? And gender is equal to female, okay? So these are my defaults, that in case someone comes and does not provide them, okay? So you see that here it was telling me that gender is not provided, but now after doing this, okay, and running this code, it's going to run and tell me that hello Jenny, your gender is female. But this is because we have told Python that actually we're telling our function that actually gender, we want it to be female by default. But if I come and put male, okay, if I come and put male, it's going to replace the original female, okay? And if I called the function without any arguments, it is still going to run. And it's going to tell me that hello, John, your gender is female. But because John is supposed to be the male, okay? So let's run it. So hello, John, your gender is male. So it's just going to tell me by default that it's going to throw the default values. Are we together at that point? Okay, so let us continue. Now, up until now, we have looked at the function, we have looked at how to define the function, we have looked at parameters, we have looked at arguments, positional arguments, we have looked at keyword arguments, we have looked at default parameters. So we originally, we saw something which was telling us that, for example, if I print, say, name, okay? We are looking at something which is none, okay? And when we were starting in our first class, I told you that we have a data type called none, okay? So now, why do we have this none here when we call our function? So when we try to print out our function. So I want to bring your attention to what we call the return keyword. So this return keyword is very, very important and you see it a lot, especially when you are dealing with functions. You'll see it very, very much. So what does return do? Let me try to say, to define a function. I say define a function. I want this function to add. It's called sum. And sum, let's say maybe it is taking in num1 and also the second number, okay? Num1 and num2, okay? So if we try to say num1, we want our function to to add these two, num1 and num2, okay? Num2. And we call the function with sum and we provide it with the numbers like maybe 2 and 3. So you see that it does not print anything. Of course, this is we already know why, because we are not returning, we're not printing anything. But what if we put a print and we say print sum of 2 and 3? We get none. So let us copy this same function here, okay? Let's keep the first one for reference, copy it here, okay? And instead say return, okay? We put a return that, what did I write here? Def. So let's put a return at the num1 and num2, okay? And call this function again with the arguments 2 and 3. So when I run that, I get a 5. What is happening? So you see that what it has done is, now let me also try to show you something else before I explain what I wanted to explain. If I say print and I put these two num1 and num2 in here, okay? It again tells me 5, but why do we actually need the return keyword? So this return keyword, what it basically does, the return keyword exits the function, okay? The return keyword ends the function, and once the return is executed, the function stops immediately, even if there are any more lines. So let me try to show you again. Now, if I try to run this function here, and down below, I say print, let me see if I will run. I run that. It is a print here. So let me remove this print and replace it with the return, this return that we had here. Okay, let me indent it properly. And I run. So when it reaches here, it stops. It does not see this line. It will return the sum of num1 and num2, and it will go back. Okay, so it will exit the function. let me try now to show you something. You see, this return keyword is something that is very, very, very useful. Okay, that is very, very useful. And let me try to show you where we basically why we would need a return. So let me say def. We define a function. Let's call it get greeting. So when I say def get greeting, and maybe I'm taking in a name, we had seen something like that. Get greeting, and we're saying name. So let's return. Yeah, now this time instead of printing, let's return and use an F string and say hello and hello name. Okay, so hello name. So if you put in John, it's supposed to tell you hello John. You can even put in an exclamation mark outside. So when I say now, when I run my function, of course, nothing because I've not yet called the function. So when I say message, okay, is equal to get greeting, and I say John, okay? So get greeting John, and now I print out the message, okay? So when I do that, it's going to tell me hello John. But now let us try it without putting. I'm still trying to stress the point of why this return keyword is useful. So let's try to copy this code, okay? But this time I say print, okay? So let me say print instead of the hello. I say print and I do something like that. And now let me run the same line of code that this same thing here, copy it, okay? And I can put it within the same cell, no problem. I want you to see what will happen. It tells me, hello, John, 9. Okay. So what is happening? What is happening is that when we run this code, when we run our code in here, the function will, whereas it is printing this statement, I don't want you to confuse printing out something with returning. This function is returning nothing. It is returning none. Now, when we do something, if the function returns nothing, it's not when let me try to maybe explain this. Let's say, like, for example, we wanted to use that name John somewhere, okay? So when we use that name, when we want to return that name John somewhere, we actually can store it and use it and use that variable that we have stored again somewhere in the code. But when the function actually returns nothing, okay? When the function returns nothing, we get a none type. We get a none type, and when we get that none type, I think it's very, very useful if I display this. But the return keyword is usually used inside the function to send a value back to where the function was called. And I say that the function is exited after that return, and no code runs after that return statement. And the return statement is basically we are trying to use it to get results from a function and store those results in a variable for further use and decide what to do next based on the result. So let us think about it in this way, maybe, that a function is a machine, for example, and the return is how the machine gives back the output after doing its work. Okay, so let me try to show you this in maybe, let's write some small program. Like for example, let's say def, maybe example. Let me just call it example. And I've written a function called example. And we return. Okay, let's use return here. Return first statement. And here, let's print this line, maybe something like that. So when I come to print our function, which is example, okay, we see that our function is returning this. It does not return it does not print out this. And this is where we are saying that it exits the function and goes back on top. Let us try to write a small, maybe a loan eligibility problem, maybe. Okay. Loan eligibility checker, something like that. Maybe we're writing a program that is going to check if someone is eligible for a loan. So let us try to write our program. What we need, maybe we need the user's income and the user's expense. Okay, the user's income and expense, and then we are going to check maybe the balance that remains after they have spent their income. I don't know if it's called disposable income or something, but we can say maybe it's disposable income, which remains after you have spent on your expenses, right? And let's say debt, okay? Check loan, maybe always make sure that you make your functions very understandable. And check loan eligibility. We want to check for the income. We want the income, and we want you to get the expenses. We want to get the expenses of the person applying for the loan. But before that, we want to make sure that we may be disposable income. And we are saying that disposable income is going to be income, okay, minus the expenses, the balance that remains after you have spent some part of the income. Now, for example, let's say if the disposable income, okay, if disposable income, this, let's say maybe if it is in our bank, we'll say maybe if it is greater or equal to 300,000, maybe, okay? If the balance after you have spent your income is greater than 300,000 or equal to 300,000, let the loan amount that we give you, let the loan amount be equal to this disposable income. Disposable income maybe time multiplied by 5. Let's say, for example, you earn $1 million, you have spent 500,000, your disposable income is now 500,000, and now since it is greater than or equal to 300,000, we give you a loan which is 500,000 times 5, so that would be something like 2.5. So now this is where the return comes in. That I want, if the disposable income is greater than or equal to 300,000, we want the loan amount to give you to be disposable income times 5. And we want our program to return something, okay? Do you qualify or do you not? So when you qualify, we return true, okay? Let's return a Boolean. So return true, and then we also tell you the loan amount that you qualify for. this loan amount that we are saying here. Okay, let it be that. Else, if you do not, okay, else let's return false. This person does not deserve a loan, of course, because their disposable income is that, and this your loan, your qualified loan would be something like 0. And now let's now collect our user input, because we want our user to be able to put in their name. We want them to put in maybe their monthly income. We also want them to put in their expenses. Okay, so we can say name maybe. Let's collect the user name. So let's of course input. Please enter name. Enter name. And let's say maybe the income, because we want the income, we want to collect that income. So the income also, now the income has to be a figure. So don't forget the int typecasting. Don't forget the typecasting. So int put, let's enter your monthly income. Okay, and then expenses, we also of course need them in integer format. Okay, so int input, enter your monthly expense. Okay, enter a monthly expense. Okay, so now after there, we say now we want to check. Let's check if this person is actually eligible. Okay, so check if they're eligible. So we're checking eligible. Okay, amount, okay, to be equal to this function that we have called check loan eligibility. Okay, we are checking eligible and the amount against check loan eligibility with the income and the expenses. Okay, so this line here. Okay, not with double. Okay, so now let's output now the result, that if you are eligible, okay, we want you to print an F string with hello. Of course, we have put in our name, hello name. You are eligible for a loan or maybe UGX. I know some of you can borrow in dollars and that rich, so the amount. Else, if not eligible, of course, you print out, let's say, let me just copy this same line. Oh, Jesus Christ. Oh, my power has gone. My power is off. Let me, I don't know how. Okay, it's back. So, okay. So is my screen is back? My power had,
yes, you can see it.
My power had disappeared. So let's say else, let me copy this and say, hello, you are not eligible for a loan. Okay, let's remove this because we are not eligible for a loan at all. So you are not eligible for a loan. So let us run this code. Oh, invalid syntax, return true and loan amount. Yeah, I missed that. So if you also missed it when you're coding along, make sure you correct that, because loan amount is this variable that we find here. So if I run that, tells me enter name. I say John. Monthly income is maybe 1 million, 1M. Monthly expense, let's make it maybe 900,000. But it's going to tell me that you are not eligible for a loan. But let us run it again and say maybe my name is John. I earn 1 million, but I have spent 200, maybe 1,000. So it's going to tell me, hello, John, you are eligible for a loan of up to 4 million. Okay, so it got that balance and multiplied it by 5. Now, where I want you to understand is the use of the true, the return keyword here, and the return. This we have been seeing. We have been seeing if statements. We have seen how to collect user input, but returning that, okay, returning what, returning true and returning false, okay, in this example is what I wanted you to understand with the return. So let us try to see what it is. Now, the return, we said that once the return is reached, usually the function stops and the values are passed back to the line where the function was called, okay? And when this function is called, this function check loan eligibility is called, it runs this whole piece of code, right? Returns this whole piece of code. And we say if that loan amount, disposable income by 5, and then return true. So returning true is basically returning to a function, telling it that actually, depending on this input that the user has put here, this person actually qualifies for a loan. And it exits the function, okay? It exits the function. It exits the function and goes on to the next line of code, which is the next part, which is going to check for the eligibility, and then it's going to tell us if this person is actually eligible or not. So the return keyword is something that you need to really get used to. Something which is you need to get used to. So just know that it sends values back, and then it ends a function execution, and then allows a result storage. That is what the return does. So I see that we are 3 minutes.
Doctor.
Yes. And
the error on I have an error.
Yeah, check your indentation, check your variables,
eligibility.
check your code properly. So in the next class, we are basically going to look at something fun. Ernest will come back and we shall do a fun project together, a very fun project. We shall generate Yaka tokens and see how, of course, it's a simulation. We shall try to look at how Yaka can be generated, how you can check for tokens, check for your balance, So just a fun project that will be taking in everything that we have covered until this point: loops, functions, strings, dictionaries, everything that we'll take in. And in the next week we shall start with OOP concepts, and we shall be, for as far as data science is concerned. As far as data science is concerned, by the way, this is where Python stops. If your mission is data science, this is where it stops. but you do not need to continue to OOP because those would be advanced concepts for a data scientist. But if you are going to continue and do things like machine learning models and all that, dealing with large language models, you need to learn the OOP concepts. But for data science, this is where no person will go beyond this, but because we want to be a little bit more, our mission is to continue. And if you want to also branch to web development with Python, if you want to jump to back-end development, stuff like that, we are still having this journey until we do OOP, error handling, and all that. So I see Rodney Chingun, do you have your hand up?
Doctor, I don't have a question, but I'm kindly requesting that you share with us this code in group.
Okay.
For practice purposes. Thank you. I will
share this this notebook. I'll share this notebook, and then we shall see what it is. So, are you guys enjoying? Are you feeling like things are moving, or are we feeling stuck? Because I feel like we have hit a stable number. We are now at 24. I know some inboxed me that they're at work and they will follow in. But are we following in? Are we enjoying? Because I really feel like we at this point we should be enjoying what is happening. And now when you start the actual data science, it will be more thrilling. I even feel like we should continue these tutorials until we even do web development with Django and maybe Flask or any Python library. I just feel so energized. So guys, let us, if we do not have questions, let us end the session from here. I want to prepare for a session I have in the morning. So have a very good night. Have a very good night. And sleep well. Keep coding. I'll share this recording. I'll share the notebook so that you can follow.
Thank you.
Thank you.
Okay. Okay.